Hello and welcome to this lab demonstration on managing resource pools. At the beginning of this lab, we already need to be familiar with the concept of VMware vSphere resource pools. In this lab, we will maintain some VMs, then we will create a CPU contention. After that, we are going to create a couple of resource pools, and finally, we are going to verify a resource pool functionality. I'm sure I provided you enough good reasons to watch the following video on managing resource pools. So let's get started. So in order to verify a possible CPU contention and the functionality of resource pools, we need to prepare a bit. Let's go to our hosts and clusters sections. Let's find our SA VCSA01 vClass local vCenter. Let's unwrap its SA data center and its SA ESXi01 vClass local ESXi host. And now we need to use two of our VMs, which are called Win1002 and Win1006. But at first, let's rename our Win1006 VM. Let's right click on it and let's choose the rename option. Let's call it Win03. Now, what we are going to do? We need to edit some settings of this VM and of our Win1002 VM. So let's begin with Win1003. Let's right click on it and let's choose the edit settings here. What are we going to do? We are going to unwrap the CPU section of the VM configuration, and let's find the particular section which is called scheduling affinity. Let's place one digit here. What are we going to do by doing this? We are going to specifically, intentionally make our SA ESXi01 ESXi host to run this VM on a particular CPU, on a CPU1. It's not recommended to do this in a production environment, but we are going to intentionally create a CPU contention. We are going to place two VMs on this particular CPU number 1 for us to be able to see the result of a CPU contention. So let's type the one digit here. Let's choose the CPU number 1 here. And now we need to edit some network configuration of this particular VM. Let's find our network adapter here. Let's unwrap it. And let's choose the different network for this particular network adapter. Let's click on Browse. Let's choose our PGSA production DVS lab network. Let's click OK. And now let's repeat those steps for our Win1002 VM. Now I'm going to click on Edit Settings for this VM. Again, I need to unwrap a CPU section, and I also need to select the same CPU for locating this particular VM, CPU number 1. And I also need to change the network settings. Let's click on Browse. Let's again choose our PGSA production. Let's click on OK and let's click on OK here. And now I'm going to power on both of those VMs. Let's right click on Win1002 and choose the power on. And let's repeat this step for our Win03 VM. Let's power them on both. So now these virtual machines are starting, their operating systems are starting. We need to wait a bit for us to be able to log in to those VMs. Let's choose our Win1002 first. Let's launch a web console for it. And without closing that tab, let's open our Win1003. It's powered on. Let's choose it. Let's launch a web console for it. I'm gonna swap those tabs. Now, what we are going to do, we need to log into our Win10.02 and Win10.03 virtual machines. Let's wait a bit for our vClass administrator account to successfully log in on those VMs. Let's give it a couple of seconds more. So now those VMs are ready. What we are going to do now, we are going to launch some CPU workload on both of those VMs. What do we need to do? We need to go to our, for example, Win10.02 at first, and we need to locate a file which is called CPU-busy. It's a specifically written script which we are going to launch here. This script is going to make some floating point computation in order to overload the CPU of this particular VM, the virtual CPU of this particular VM. So we need to right click on this CPU-busy script, and we need to choose the Open with Command Prompt option here. Now this script is going to launch. I'm going to repeat this step on our Win10.03. Again, I need to find the CPU-busy script here. I'm going to right click on it and click Open with Command Prompt. Now we actually need to wait for a couple of minutes for this script to fully warm up. We can see that for every 5 or 6 seconds, this particular script is generating some workload. For example, it says ID 10 million signs in 6 seconds and so on. We can see that this number is almost constant here with only 1.5 in the line of 6 seconds. And we can click on our Win10.03. Again, we can see that some of those computations are made in 6 seconds, some of those computations are made in 5 seconds. We can actually wait for a couple of minutes for these scripts to warm up. But what we can do simultaneously, we are going to prepare for our next task. What we are going to do, we need to create 2 resource pools, specifically configured. So what do we need to do? We need to find our SA ESXi01 vClass local. Let's right click on it. And we are going to create 2 resource pools, which we are going to call, one resource pool is going to be called RP test, and the second resource pool is going to be called RP production. So let's find the new resource pool option here. What we are going to do, we are going to create a resource pool, which let's create a test resource pool first. Let's call it RP test. And let's choose a CPU shares option. Let's set it to low. We can see that its width has been changed to 2000. We are not going to configure any other options here like reservations, reservations tab, and reservations type, and so on. And currently we are going to focus only on the CPU section of this particular resource pool. So let's click on it. Now this particular resource pool has been created. Let's repeat this step and create another resource pool. Let's call it RP production. RP production. And now we are going to select the shares option for this particular resource pool, and we are going to set it to high. And we can see the width has become equal to 8000. Let's click on OK. Now we have 2 empty resource pools. Let's go back to our Win10.02 VM. Now we can see again that most of our tests most of our floating point computations are completed in 6 seconds, and some of those are a bit longer or a bit shorter, but the most popular digit here is 6. And for our VN1003, again, the most computations are completed in 6 seconds. So those numbers are quite equal. Both VMs can complete their computations in somewhere around 6 seconds. Let's change it. Let's divide the CPU share, the CPU time of that CPU1 CPU where we have located our virtual machines intentionally. Let's divide that CPU time unequally between these VMs. So what we are going to do? We are going to drag and drop our VN1002 to our RP production resource pool. And now this process has been completed. And we are going to drag and drop our VN1003 to our RP test resource pool. What we have done here, we are intentionally placing our VN1002 in an RP production resource pool, which has 8,000 of CPU shares, and our VN1003 in RP test, which in turn has a number of 2,000 CPU shares, so 4 times lower than RP production. And now we can actually see the result. Again, we need to wait for maybe somewhere around of 1 minute to see the actual result, but let's go to our VN1002. Now we can see that the largest number of our computations are now finished in 3 or 4 seconds. So let's remember this number. Let's go to our VN1003. And now we can see that our average number of 6 seconds for every computation has been changed to 16, 16, 15, and now we can even see the 69 number. Let's wait for a couple of seconds again. Let's see the actual proportion between those numbers. Here we can see a stable number of 3 seconds for every computation. Let's wait a bit here. Let's see at least 2 computations more. Again, this difference can also be described because of some time we need to wait to actually for those scripts to actually warm up and to adapt to a new environment, to a new CPU settings for our VMs. 69. Let's see some other numbers here. Again, if we see our VN1002, the number 3 has been stabilized. And here we see that our 69 is still the last number here. Now we can see the 93 seconds for the second test, and so on. So because of our resource pool inequality, we see that our RP production and its VMs, like VN1002, achieves significantly more CPU time resources, at least 4 times more than our VN1003, that we can actually see the result in those numbers, in the number of the amount of computation, of amount of seconds, I'm sorry, for the script to be able to finish its computations. So let's change those numbers. Let's see the result if we change some numbers there. Let's find our RP production resource pool. Let's set it, just a second. Let's edit it, edit resource settings. Let's change the CPU shares from high to normal. And here we can see the exact weight now is equal to 4000 instead of 8. Let's click on OK. Let's go back to our RP test now. Edit resource settings. Let's choose the normal section here. Again, we can see that normal equals to 4000 of CPU shares. Let's click OK. The CPU scheduler of this particular ESXi host needs a couple of seconds to actually create a result from our configuration. Let's go back to our VN10.02. Here we can see that our last test has been completed in 32 seconds. Let's wait at least 2 more computations here. Let's go back to our VN10.03. Here we can see that our last computation was finished in 105 seconds. Again, let's wait for a couple of minutes to see the actual result. I'm going to pause this video for us to be able to see the some number of those computations after our configuration changes. After a couple of minutes, we can see that after a warm-up, our CPU floating point computations have been almost stabilized. Let's see our VN10.03. I can see that many of those computations have been completed in 5 or 6 or 7 seconds. And if I return to my VN10.02, I can see that again, most of those computations are now completed in 5 or 6 seconds. So let's stop this process from happening. Let's close those scripts. Let's shut down both of our VMs. And now our lab is completed. Congratulations, you have completed the Managing Resource Pools lab demonstration video. During this lab, we have seen how we can create a CPU contention for testing purposes, what do we need to do to create resource pools, and finally, how we can verify the functionality of a resource pool. Thank you for watching this lab demonstration video. I hope the knowledge acquired here will help you with your daily job assignments, and good luck as you continue your journey in VMware world.